Next week.
Oh, I know that now.
All right, so here we go. Attention up here, please. Okay, so what we're going to look at today, the first section is really, 6-1 is, it'll take you, no kidding, probably like, I don't know, 4 or 5 minutes. Not long at all. Very introductory. This is not a huge deal either. This section, or this chapter it's really just about, a lot of it's about classifying quadrilaterals. And that's what we're going to start doing today. So today we're going to talk about properties of parallelograms. The goal for the day is really just that you can recognize and use some properties of parallelograms. That's it. Okay. All right, so real quick definition of a parallelogram. So a parallelogram is what it sounds like. A parallelogram is a quadrilateral. Now what's that mean? What's quadrilateral? Four-sided polygon, right? Quad means four. So lateral means side, quad means four, so it's exactly what it says also. Quadrilateral is four-sided figure, and it's a polygon, so it's got straight sides. Parallelogram is a quadrilateral with two pairs of parallel sides. That's it, right? So this is representative of the category or the class of all quadrilaterals. What's it mean, or parallelograms, sorry. What's it mean that we've got these one arrows and these double arrows? Remind us. Parallel, okay, good. So one arrow side is parallel to the one arrow side. Two arrow side is parallel to the two arrow side, good. So that's the definition, a quadrilateral with two pairs of parallel sides. If a quadrilateral is that, then it's a parallelogram. This is the symbol for parallelogram that you'll sometimes see. It just kind of looks like that picture. Okay, so 4 properties. There's 4 properties I want you to get familiar with. I'm going to summarize these. So all of these properties, which are theorems, they're going to fit that pattern of a conditional statement that we've seen a lot in geometry. If something, then something. So in this case, if a quadrilateral is a parallelogram, and all 4 of these relationships, these properties start that way, if a quadrilateral is a parallelogram, then something is true. Okay? So one thing that's true is if the quadrilateral is a parallelogram, then its opposite sides are always congruent. Okay? That doesn't mean that all 4 sides are congruent. It just means that the opposite sides are congruent to each other. Okay? So in this case, that means that side PQ is congruent to side RS or SR, whatever you want to say it, and side SP is congruent to side QR. Okay? Something else that's always true. If a quadrilateral is a parallelogram, then guaranteed the opposite angles are congruent. Okay? It doesn't mean that all 4 angles are congruent to each other, but each pair of opposite angles guaranteed are going to be congruent. Okay? Something else that's true about the angles. If the quadrilateral is a parallelogram, then not only are opposite angles congruent, but consecutive angles. What's consecutive mean? What's the word consecutive mean in this case? What's that mean? Alec, why don't you get rid of that, please? What's it? No, consecutive. What's that? One after another, or in a row, right? So consecutive angles are supplementary. So if I'm moving around the outside of the parallelogram, any 2 angles that I encounter that are in a row or consecutive are guaranteed to be supplementary. So measure or angle Q and angle R are supplementary. Angle Q and angle P are supplementary. Angle P and angle S are supplementary, etc. Right? Any 2 consecutive ones are always supplementary. All right. And then the last thing has to do with diagonals. If the quadrilateral is a parallelogram, then we always know that the diagonals are going to bisect each other. So the intersection is going to be the midpoint of both diagonals. So what's it mean to bisect again? Remind us, somebody? Cut in half, right? So we're going to cut it into 2 equal lengths in this case, or 2 congruent segments, right? So then that's telling us that, for example, segment QM is gonna be congruent to segment SM. Yes, sir.
What was the last one you said?
So there we got, see if we can remember these. What's the first one you said? If parallelogram, opposite sides congruent. Second one, if parallelogram, say it again, opposite angles are congruent. If parallelogram, what else is true about the angles? Consecutive angles are supplementary. Good. Okay. And then finally, the last one, if parallelogram, then diagonals bisect. Yeah, good. Okay. So QM's congruent to SM, PM's congruent to RM. Okay, and that's it. We got those 4 things for free if we know it's a parallelogram. All right, so let's fill in a couple blanks here. You tell me. Okay. Let's fill in the blanks. So if we're told that FGHJ is a parallelogram, and the arrows mean that anyway, right? We're given some information here about some side lengths. What does the length of segment JH have to be based on this picture? So that's what, remember, that's what a J followed by an H means, right? You want a length of that segment. What do you think? What's it gotta be? 5, how come?
Because it's parallel to segment FG.
Okay, so FG, so we can see that it's a parallelogram because we got 2 pairs of opposite parallel sides. It's telling us that the length of FG is 5. And change one word about what you just said. We know that segment FG or side FG and what others and side JH are what? Congruent. Yeah, they got to be congruent because they're opposite sides, right? And in a parallelogram, opposite sides are always congruent, so we know the length of this side is 5. Could we know, based on the information that we're given here, could we know the length of FJ? We can't we? We're not really given anything here that helps us out. In order to know the length of FJ, we'd probably have to know maybe the length of this side over here, right? We don't have that. Does that make sense? Okay, so Shah, what about JK, the length of segment JK? What do you think? They're telling us, they only really give us 2 things here. 3, yeah, how come?
Bisect each other?
Yeah, perfect. Okay, because we know that this is a parallelogram, so we know that the diagonals have to bisect each other, and so that tells me that this diagonal has been cut into 2 congruent parts with equal lengths, right? Okay. All right, how about some angle stuff then? What about this? Take a look at the picture. Okay, so we know it's a parallelogram. PQRS is a parallelogram. So based on what we're given there, can somebody, Cassidy, what's the measure of angle R and why? Why did you get your answer? So we're looking for the measure of angle R.
Marshall's got it, bro.
No, I don't even know. Casting, it's 70, isn't it?
It is?
Yeah.
Okay, how come?
Because they're opposites.
They're opposite angles.
They're
Good.
opposite.
If parallelogram, then opposite angles are congruent.
Can you move up a little bit? Yeah, you just
Check
move
it.
up a little bit.
Okay, what about, everybody see that? Okay, so we know if it's a parallelogram, we know opposite angles are congruent. So that's gotta be That's gotta be 70 degrees also, right? Okay, so what else? Abby, what about the measure of angle Q? It's gonna be the same as measure of angle S, that's true. We don't know the measure of angle S though, so can we figure it out? Is there a different relationship we could use there? Ah, supplementary. Okay, so what's it gonna be then? Okay, 110. Because remember what supplementary means. Supplementary means the measures have to add to 180, right? So we know then that if these two have to add to 180, there's gotta be 110 degrees left over, right? Does that make sense?
Yes.
Okay, good. Okay, let's see here. Now I want you to hey, listen, up, come on, we're getting a little squirrely here. Let's go, we're almost done. Okay, Danny, help me out here. We want to find the value of x. So anytime, we always know if we're going to find the value of x, we're solving an algebra equation, right? We got to solve for the variable. Before we can jump into that, we got to think about the geometry part that feeds us the equation. So what's going to be the or what's the relationship that's going to be important here? Put that if you got something on.
120 plus 3x equals 180.
Good. They're supplementary, right? Okay, good. So we know that the two angles are supplementary, so that lets us set up an equation. Okay? And then now we can just shift into algebra mode. It's pretty easy, right? What are the two steps we do to solve for x?
Minus 120 divided by 3.
Good. Subtract 120, divide by 3, we get 20. How can we check it?
Substitute.
Substitute it back in and just see if it works, right? Okay, good. All right. I think maybe.
You gotta go over there, and I won't make this.
See if we can actually come up with a proof. So we're trying to show here, we're trying to prove that angle 1 is congruent to angle 3 if we're given that quadrilateral ABCD is a parallelogram and so is AEFG. Now it might be helpful here, how about if we color code those so we can, so we'll make this one red. ABCD, so that's this guy, right? And how about if we make this one blue? Okay, so what would, thinking, going back to proofs, we haven't done these in quite a while. What's the first step in the proof probably going to be?
The given.
Given stuff, sure. So, okay, we know that these are both parallelograms. Okay, so that's given. Now what? Any ideas? And they gave us a little bit of a hint here, right? They added this angle 2, which wasn't included in either the given information, what we're trying to prove, but maybe it's important. Okay?
DV3.
Say it again.
With DV3.
Oh, you're saying this angle right here? Yeah, it would. It would. But now think about this just as either just the red parallelogram, because that we know is a parallelogram, and the blue one is a parallelogram.
Would angle 2 and 3 be the same?
Okay, angle 2 and angle 3 would be congruent. How come? Okay, because they're opposite angles. Good.
Then 2 and 1.
And then 1 and 2 are also, right? So if we look just at the red parallelogram, we can see that 1 and 2 are opposite angles, so they have to be congruent. If we look just at the blue one, 2 and 3 are opposite angles, so they have to be congruent.
So we have to.
Good. And so now we can add, let's go ahead and add those marks to our drawing. So that's congruent to that, and that's congruent to that. And so does anybody remember what, Kylie, do you remember what that step is then? So if we know that 1's congruent to 2 and 3's congruent to 2, why is 1 congruent to 3? Do you remember? Yeah, remember what the name of that is? The middleman one?
Yeah.
Not that one, but if we're gonna transfer the congruence through the middleman, right? So 1's congruent to 2 and 3's congruent to 2. Remember that?
I know what you're saying, but yeah. I remember.
Okay, so we got the second one, the third one, it's the transitive property, right? Now, you'll be able to look, anytime you're doing proof stuff, I'll give you the list, the updated list that you can always look off of, right? So, but remember, that's just so you kind of, so that's jogging your memory a little bit. Transitive is the middleman stuff in geometry. Okay, I think that's it. Yep. Okay, we're good. So let's go ahead, we got a little time, don't we?
Yeah.
Okay.